Hello friends, welcome to Physics with Ben. Don't forget to subscribe, like, comment and share this video to those that need it. This is a continuation on the video series on scalar and vector quantities. You may love to click in the description on this video you are watching to find a link to the first video on this topic, the introduction to scalar and vector quantities. In that video, I promise the second video, and this is the video. Please endeavor to watch all the video series on this topic. It's a very broad topic, and let's watch all the video series till the end. In today's class, I want us to look at the topic before us, the subtopic before us, finding the resultant vector using the parallelogram method. In finding the resultant vector using the parallelogram method is simply what we call using the simple geometrical method. In this method, we are going to revisit cosine and sine rule in mathematics. If you have abandoned that topic or have let go of that topic for quite a long time, I am advising you to kindly revisit that topic. I will surely do a video on that topic, but I want to concentrate on this one for now. So without wasting more time, let us go straight to the business of the day. In looking at the parallelogram method of finding the resultant vector, examiners will ask you to state the parallelogram law of vectors. So let us look at this law, the parallelogram law of vectors. This law is very important. You may pick up your pen and state this law with me. Are you ready? Good. Right. The parallelogram law of vectors states that if two vectors are represented in magnitude and direction by the adjacent side of the parallelogram, the diagonal drawn from the point of intersection of these two vectors represents the resultant vector in magnitude and in direction. I state that law again. If two vectors are represented in magnitude and in direction by the adjacent sides of the parallelogram, the diagonal drawn from the point of intersection represents the resultant vector in magnitude and in direction. So the diagram I just drew here is a perfect pictorial representation of this law. You see, this longest line inside this diagram is the diagonal, and it is drawn from the point of intersection of this vector. The vectors are inclined at an acute angle with each other. There are moments this vector may be inclined at an obtuse angle, and we are going to look at all of that in this video. So if we name this is your A, this is your B, and this is your C, and this is your D. We have to revisit some mathematics here, the cosine rule and the sine rule, or the addition of triangles. Now let's move straight to the next part. There are moments the two vectors f1 and f2 may be inclined at an obtuse angle. In that case, this is what you have. If the vectors are inclined at an obtuse angle, the diagonal is still this. and then this is how you draw it. Good. This is your F1, and this is your F2, and this is your F. Now, in defining this law, we can represent this diagram and this diagram with mathematical equation. Now, recall that from cosine rule is used in finding the sides and the angle of a triangle. When the triangle before you is a right angle triangle, you make use of Pythagoras theory, as I said in the other video. When the triangle before you is not a right angle triangle, maybe an obtuse angle triangle or an acute angle triangle, that is where you make use of the cosine rule or the sine rule. And if you can remember your cosine rule very well, cosine rule states mathematically as follows, that your a square is equals to your b square plus your c square minus 2bc and then cos a. That is your cosine rule. So if we want to make this rule look like a physics rule, we are going to write that from here, if we are finding the resultant vector f, we write that f squared is equals to f1 square plus f2 square minus 2f1 f2 cos d. That is how we are going to write it. So the same thing applies here. If we want to find the resultant vector f, we still write the same equation. So the equation in finding the resultant vector when the vectors are acting at acute or obtuse angle from the law of the or from the parallelogram law of vectors is written as follows. From cosine rule, we have a square is equals to b square plus c square minus 2bc cos a. So what we do is that mathematics loves using the symbols, but in physics, we use the actual uh, symbols for our quantities. In physics, we're not going to write A, B, C, or D, but we're going to use F for force, we're going to use A for acceleration, and V for velocity. So we can customize this equation to look like a physics equation by saying that f squared is equals to f squared is equals to your f1 square plus your f2 square minus 2 f1 f2 cos theta or cos alpha. In that case, from the diagram, we have it as cos d. And if it is if what you see here is not a force, but let's say maybe this was velocity, maybe v1, this was velocity again, maybe this is your v2. So how do you represent this equation? In that case, you write that your v square is equals to your v1 square plus your v2 square minus 2v1 v2 cos d. So you see that we have customized that equation to look like a physics equation. Let me give us a typical example on how to make use of cosine rule or sine rule in this topic. Now, let's suppose, example, example 1. Let's suppose these forces are acting at an angle, let's say 45 degrees to each other. And we are asked, and let's say the force here is just, this is F1, and your F1, let's say, is 2 Newton. And then this is your F3, your F2, and your F2 is let's say 4 Newton. And then you are asked to find the resultant vector in magnitude and in direction. How do you go about it? It's a typical example of the parallelogram law of vectors and finding the resultant vector using the parallelogram method. This is a typical example of that. So the next thing for you to do is for you to complete the parallelogram. What do you do? From that law, you draw a straight line from the point of intersection here. And this straight line stands for the resultant vector F. You now complete the parallelogram by putting dotted lines here. Now, there are some basic stuff that you need to know here. You know that the size of the parallel side of the parallelogram, they are equal. This side is equal to this. And so up here is still your 4 Newton. Here too is your 2 Newton. The parallel side of a parallelogram, they are the same. Now, the opposite angles of the parallelogram, they are also the same. So it means that this angle too is 45 degrees. And then this angle and this angle are the same. The next thing you need to know about the parallelogram is that the sum of angles inside this parallelogram is equal to 360 degrees. 360 degrees. So if you are having 45, okay, if we name this angle, let's say our angle A, B, C, and D. So if angle A is 45 degrees, it also means that angle C is 45 degrees. So angle C plus angle A will give you 90 degrees. So how do you find angle B and angle D? So you just say your 360 degrees minus 90 degrees. And that will give you 270. You're going to have 270. But then, since angle D and angle B are equal, you say 270 divided by 2. 270 divided by 2, and that will give you 135. So here you have 135 degrees. Here too is angle B too is 135 degrees. So actually the question will be given to you as 45 degrees, but what you are going to use in calculation is not 45 degrees, but the angle 135 degrees. So if you detach angle CAD away from this parallelogram, this is what you are going to have. You're going to have something like this. Look at that. You're going to have something like this. Good. So this is your A, and this is your C, and this is your D, and this is your 135 degrees. Don't forget that there was another angle here. We can call this angle your phi. And then this angle phi is what you are going to use to find the direction of the vector. So right here we have angle gamma. This is gamma, not phi. That is gamma. So our gamma is equal to that. and this angle here is not yet given. And then here is your resultant f, and here is your f2, and here is your f1. Don't forget your f2 was what? Our f2 was 4 Newton, and then our f1 was 2 Newton. So we have 4 Newton here, and then we have 2 Newton on this side. So now, how do you make use of cosine rule? You can only make use of cosine rule when the two adjacent sides are given with an angle in between them. In this case, you can see that side AD is given to be 4 Newton and side DC is given to be 2 Newton. And then in between side AD and DC, you have an angle 135. At this point, you are free to use cosine rule. You can only use cosine rule when this particular condition is met. But when the two adjacent sides are not given, then you are going to use the sine rule. So in this case, I can equally state the sine rule here before we proceed solving this equation. From here, we have that our sine rule, and let's suppose this is my A, C, D. For mathematics, you know that here is your side D, and here is your small a, and here is your small c. This is what we have in mathematics. So that if you want to find, if we can name these angles, let's say this is your gamma, this is your beta, and this is your phi. This is your phi. So, but we're not going to use those symbols in. We're going to use it outside. The A, C, the uppercase A, C, D stands for the angles. Y small d, small a, and small letter c stand for the sides. So from sine rule, you can write that sine capital A divided by small a is equals to sine capital B divided by small b is equals to sine capital D divided by small d. Alternatively, you can write that small a all over sine capital A is equals to small b all over sine capital B is equals to small d all over sine capital what? D. So this is exactly what we do in physics. So if you come back here, applying that here, we can write that from here. If you want to use sine rule, you can write that sine gamma divided by 2 Newton is equals to what? If we name this angle as beta, we can now say that sine beta divided by 4 Newton is equals to sine 135 divided by f. This is how to go about it. And so you see what I did. So if we are going to use the cosine rule, I said for the cosine rule that when the two adjacent sides are given and an angle are given in between, you go ahead and make use of cosine rule. So let us apply cosine rule on this particular diagram and find the resultant vector. So from there, we write that from f squared is equals to f1 square plus F2 square minus 2 F1 F2 cos 135. We substitute at this point. Our F1 is 2 Newton, so we'll write 2 square. We'll write 2 squared plus 4 squared minus 2 into 2 times 4. And if you press cos 135, you are going to have minus 0.7072 minus 7071. If we evaluate correctly, 2 square is 4 and 4 square is 16, and so you have 2 minus 2 into 8. That will give you 16 again. Okay, let me do step by step. 2 into 8. 2 into 8 times minus 0.7071. If you evaluate that correctly, you have 16 plus 4 will give you 20. You have 20 minus 16. 20 minus 16 times minus 0.7071. If you evaluate that correctly, you have 16 times minus 16 times 0.7071. That will give you plus 11. So we write that our f squared is equals to 20 plus 11.3136. So the summation of that will give you 20 plus 11.3136. That will give us 31.3135. So we'll write that our f squared times 1 over 2 is equals to this times 1 all over 2, the index of 1 over 2, and that will give us the root of 31.3135. If you evaluate that correctly, you have the roots of that. You're going to have 5.596 Newton. 6 Newton. Therefore, the resultant force F is equals to 5.5958 Newton. But this is not all. Anytime you are representing a vector quantity, for that vector quantity to be represented completely, the vector quantity must be represented in magnitude and in direction. So right now, what do? We got to find the direction of this vector. So we can say that from this diagram, this is what we have right now. Let me redraw this. This is what we have right now. So right now, we have our f to be equals to, let's write this to 1 dp, 5.6 Newton. and this is our A, and this is our C, and this is our D. Our D was 135 degrees. So to find the direction, of this vector, we're gonna find it using this angle gamma, and that will lead us into using the sine rule. So you can see that the cosine rule and the sine rule, they are used interchangeably in the parallelogram method of finding the resultant vector. So right now we know that this side AD was 4 Newton and side DC was 2 Newton. So by this we can now apply our sine rule to find the direction of this vector. So we write that the direction of this vector is given as sine gamma. I write that again. Sine gamma divided by 2 Newton is equals to sine 135 is equal to sine 135. We have it that sine gamma divided by 2 Newton is equals to what? Is equals to sine 135 is equals to sine 135 divided by 5.6 Newton divided by what? 5.6 Newton. Yes, these are what we need. We don't need to equate it to sine C, or sine C divided by sine 4. Why? Because the angle C is not given. So if we do that, we're going to be finding two unknown at the same time. So this is what we are working with right now. So at this point, we cross multiply. So write that 2 Newton times sine 100. Sorry, this is sine 135. This is sine 135. This is sine 135 degrees divided by 5.6 Newton. So rather 2 Newton times sine 135. Sine 135 will give us plus 0.7071, and this is equals to 5.6 Newton times sine gamma. So 2 times 2 times 0.7071 will give us 1.4142 Newton, and we know that we have 5.6 Newton times sine gamma. So write that this is equals to 5.6 Newton times sine gamma. So we may flip this. This implies that sine gamma times 5.6 Newton is the same thing as 1.4142 Newton. So at this point, we divide both sides by 5.6 Newton. 5.6 Newton. So that this will go, this will go, Newton will cancel out Newton, and you are left with sine. You are left with sine gamma is equals to 1.4142 divided by 5.6 divided by 5.6. Do that correctly. If you evaluate that correctly, you have 1.4142 divided by 5.6. That will give you 0.2. Let me write it this way. That will give you, this is the same thing as, that will give you 0.2525. Let's stop there. So sine gamma is that. At this point, you divide both sides by sine. Both sides by sine. This will go, this will go. So that your gamma becomes the sine inverse of 0.2525. If you evaluate that correctly, your gamma is given to be the sine inverse of that. You're going to have 14.628 degrees. So that is the angle. So if you go back, this angle A, which is gamma, is 14.62 degrees. So at this point, how do we write our final answer? This is how we write our final answer. Remember, the magnitude of this vector was 5, of this resultant vector was 5.6 Newton. So our final answer will look like this. The vector is given to be what? 5.6 Newton at 14.6 degrees to the what? To the 4 Newton what? Force. Our resultant vector is 5.6 Newton at 14.6 degrees to the 4 Newton force. This is how you state your answer for the vector in magnitude, which is this, and in direction, which is this. To this, we have come to the end of this particular video. Our next video will be on how to do a lot of calculations in vector quantity. In summary, this is where we started. We started here, Parallelogram Law of Vectors. The law was stated. We look at how the angles, when they are inclined, at acute and obtuse. We look at the customization of this mathematical equation into physics equation. Back to this stage, here. Don't forget to hit the subscribe button. Thank you. God bless you. Bye-bye.